First question we need to start on. The drivers in New York State drive 2.8 times 10 to the 8th miles on Monday. Tuesday they drive extra and they do an additional 9 times 10 to the 8th more miles. Express the total distance on July 4th in scientific notation. Again, every time we get one of these questions in scientific notation, it's recommended you switch to regular numbers. The drivers in New York State drive 3 miles on Monday. On Tuesday, they drive more. They drive another 9 miles. If you drive 3 miles on Monday and 9 miles on Tuesday, how far did you go altogether? Talk to me. 3 on Monday, 9 on Tuesday. How far altogether? 12. How did you get 12? Add, subtract, multiply, divide. Add. So now I need to add these numbers. And whenever we do scientific notation, we add using writing the whole numbers out. We don't add them when they're in scientific notation form. So, the first number is 2.8 times 10 to the 8th. That looks like this. That's 6, 7, 8. There's 2.8 times 10 to the 8th. Now the next one is 9 times 10 to the 8th. That looks like this. 3, 3, there. Adding them up, I get 0, 0, 0, 0, 0, 0, 0, 8, 11. Now put it in scientific notation. 3, 6, 9 places. 1.18 times 10 to the 9th. And that is my answer. Yes? No, not now. 1.18 times 10 to the 9th. Any questions about that? Okay, on your state test and then on our final exam, there's times when you work with scientific notation, adding, subtracting, multiplying, and dividing. You have to remember, for adding and subtracting, you first convert them to regular numbers like this. Do the operation and then convert back. That's the safest way to do it. Okay. What's the image of the point 5, negative 4? So let's draw my little scrap paper over here. 1, 2, 3, 4, 5. 1, 2, 3, 4. There is 5, negative 4. Dilation, magic word! What do I do? Multiply by negative 2. So this would become negative 10, positive 8. Okay? Image in a reflection in the x-axis. Oh, and this time it wants 2, negative 3. 2, negative 3. That's down here. Reflect in the x-axis. 1, 2, 3, 1, 2, 3. I'm flipping it. The x is staying the same. The y is going to get negated. That would be 2, 3. What about over the x-axis? 1, 2, 1, 2. This time the x gets negated. Negative 2, negative 3. What about a rotation in 90 degrees? If I spin 90 degrees, that means I'm going to go up this way. That would mean I go to 3, 2. The computer can do an operation in 8.1 times 10 to the negative 5th seconds. How many can it do in 1 hour? So we talked about this the other day. This means it can do 8.1 times 10 to the 5th in a second. And then how many seconds are in an hour? The other day we did 60 seconds in a minute times 60 seconds in an hour. That gave me 3,600. Converting to scientific notation, that was 3.6 times 10 to the 3rd. Can somebody do 8.1 times 3.6? Should be like 28-ish.
29.16.
29.16 times 10 to the 8th. But this is not in scientific notation. I got to move one more point. That means I need to divide by 10. So then I have to times by 10, and I get 2.916 times 10 to the 9th. Okay? Any questions at all? Now, your next test is going to be chock full of these kind of questions. And I made a little adjustment to our schedule. We were going to have a group quiz tomorrow. Now we're going to have the group quiz Friday. So we'll just do a lesson tomorrow. We'll do a lesson the day after. Friday you'll have a group quiz. You'll have the homework on Friday night. You can enjoy your weekend.
Thank you.
Then when we come back Monday, we'll finish up a little bit more work on stuff. And then we will get ready for our test. Okay, we need to be able to recognize all the different types of transformations. So here are our choices. Ready? Choice one, hey! Choice one, reflection. Choice two, rotation. Choice three is a translation. Choice four is a dilation. So, take a look at the first diagram right here. Which of those choices is it? Is that a picture of a reflection, a rotation, a translation, or a dilation? What is that a picture of? Translation. We are sliding it. Translation is a slide. Moving it over. Here, here, boom, all done. What about number two with the pink figures? Is that going to be a rotation? It's spinning. Very good. What about number three? Brown 60s figure to blue 60s figure. Translation. Again, it's sliding over. What about yellow triangle to gray triangle? That's also a translation. Look, I'm moving down 3 over 4. That's a slide. Slides are transformations. Let's take a look here. First one, what do we got? Rotation. We're spinning it. Next one.
Reflection.
Reflection. Very good. What do we got now?
Dilation.
And the second one.
Dilation.
Dilation as well. In both cases, they're getting bigger. Their size is not staying the same. Okay. Now, here we go. We're going to take and use this as scrap paper, the point -2, -5. And we're going to do all 6 of these transformations to it. Start up on that. Let's see what you get. Get stuck, you want to talk to the person next to you, feel free. Give you about 2 minutes to get that done, then we'll go over them. Yes? I'm sorry? Never mind. If you get stuck, feel free to get help. I think some of these are going to be pretty easy. About 30 more seconds. Okay. Take a look at what we got here. Point, -2, -5. -2, -5. Where? Behave. There it is. So let's get some answers here. Dilation of 4. Magic word! Multiply. Times 4 would give me -8.
Negative.
Negative
No, sorry, negative 20.
20. Good. A slide, 5 to the right and 3 up. Ready? 1, 2, 3, 4, 5. 1, 2, 3. That's the point 3, -2. Now I could also say 5 to the right adds 5, -2 plus 5, and 3 up is -5 plus 3, and that would give me 3, -2. So either way, I end up with 3, -2. Rotate 90 degrees. That's spin it this way. I come up with 5, -2. We good on that? Very hard for me to demonstrate that. If you get it, they're easy. If you don't get it, have somebody show you next to you. God bless. Reflection over the x-axis. Count and repeat. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That would be 2, -2. I'm sorry. Count of 5. Rotate 180. This would spin all the way around and end up here. That would be 2, 5. Reflection over the y-axis. Go this way. 1, 2, 1, 2. That'll be the point 2, -5. Remember, when you reflect over the y-axis, the y stays the same. When you reflect over the x-axis, the x stays the same. Are there any questions? Okay, what we have here is, today is just a review day. We reviewed everything. We kind of make sure you're understanding what you're supposed to do with this. What I would suggest now is that you begin your homework, and if I were you, I would start working with the people that you're sitting around. Get that work started. You may even be able to finish it before we leave. We don't usually get this kind of time to do homework.